Hello friends, welcome to the another video of Startup and Recommissioning of KUKA Robot. Let's continue from modifying software limit switches. There are two ways of modifying the software limit switches. Enter the desired values manually or automatically adapt the limit switches to one or more programs. The robot controller determines the minimum and maximum access positions occurring in the program. These values can then be set as software limit switches. Precondition: expert user group, T1, T2 or automatic mode. Procedure: modifying software limit switches manually. In the main menu, select Startup, Service, Software Limit Switch. The software limit switch window is opened. Modify the limit switches as required in the columns negative and positive. Save the changes with Save. Adapting software limit switches to a program. In the main menu, select Startup, Service, Software Limit Switch. The software limit switch window is opened. Click on Auto Detection. The following message is displayed. Auto detection is running. Start the program to which the limit switches are to be adapted. Execute the program completely and then cancel it. The maximum and minimum position reached by each axis is displayed in the software limit switch window. Repeat step 3 for all programs to which the limit switches are to be adapted. The maximum and minimum position reached by each axis in all executed programs is displayed in the software limit switch window. Once all desired programs have been executed, press End in the software limit switch window. Press Save to save the determined values as software limit switches. If required, modify the automatically determined values manually. Recommendation: reduce the determined minimum values by 5 degree. Increase the determined maximum values by 5 degree. This margin prevents the access from reaching the limit switches during program execution and thus triggering a stop. Save the changes with Save. Description: software limit switch window. Current negative limit switch. Second, current positive of the axis. Third, current positive limit switch during automatic determination. Fourth, minimum position of the axis since the start of determination. 5. Maximum position of the axis since the start of determination. Buttons. The following buttons are available only in the expert user group. Auto detection starts the automatic determination. The robot controller writes the minimum and maximum positions adopted by the axis from now on to the columns minimum and maximum in the software limit switch window. Ends the automatic determination, transfers the calculated minimum and maximum positions to the columns negative and positive but does not yet save them. Save saves the value in the columns negative and positive as software limit switches. Next is calibration. Defining the tool direction. Description: by default, the axis is defined in the system as the tool direction. The tool direction can be changed using the system variable tool direction. The change relates only to line motions. For align and CIRC motions, the tool direction is the x-axis and cannot be changed. The change applies to all tools. It is not possible to define different tool directions for different tools. Warning: the tool direction must be defined before calibration and before program creation. It cannot be modified subsequently. Failure to observe this may result in unexpected changes to the motion characteristics of the robot. Death to persons, severe injuries or considerable damage to property may result. Precondition: expert user group. Procedure: set the system variable tool direction to the desired value in the file custom.dat located in the directory. Possible values X. It is not possible to modify tool direction by means of the variable creation function or by writing to the variable from the program. Next is tool calibration. Description: during tool calibration, the user assigns a Cartesian coordinate system coordinate system to the tool mounted on the mounting flange. The tool coordinate system has its origin at a user-defined point. This is called the TCP, tool center point. The TCP is generally situated at the working point of the tool. In the case of a fixed tool, the type of calibration described here must not be used. A separate type of calibration must be used for fixed tools. Advantages of tool calibration. The tool can be moved in a straight line in the tool direction. The tool can be rotated about the TCP without changing the position of the TCP. In program mode, the program velocity is maintained at the TCP along the path. A maximum of 16 tool coordinate system can be saved. Variable tool data. The following data are saved: XYZ. Origin of the tool coordinate system relative to the flange coordinate system. ABC. Orientation of the tool coordinate system relative to the flange coordinate system. Overview. Tool calibration consists of two steps. 1. Definition of the origin of the tool coordinate system. The following methods are available: XYZ 4 point, XYZ reference. Second, definition of the orientation of the tool coordinate system. The following methods are available: ABC 2 point, ABC world. If the calibration data are already known, they can enter directly. That's it for today's video. In the next video, we'll continue from TCP calibration XYZ 4 point method.